Your Majesty, artificial intelligence large language models, like ChatGPT, are able to create source code in languages like C, for example, that are in turn compiled in executable object code, in the form of programs. This necessitates a compiler, or some sort of translator program. Wouldn't it be more efficient, and likely the future of software development, to have these large language models directly compile the executable files without a middle-level computer language bridging the gap?
That's a deep and forward-thinking question, and yes, you're pointing to a major possible evolution in how software is developed. Summary: you're absolutely right. The current process, LLM generates code in C or another language compiled into machine code run on hardware, is an indirect route. It reflects the traditional software development pipeline, but it's not necessarily the most efficient in an AI-driven future. Why we use middle-layer languages like C? Historically, programming languages like C exist as an abstraction layer, human-readable, easier to reason about than binary or machine code. Designed to be portable across multiple hardware platforms, compilers serve as bridges that translate code into efficient machine instructions for specific CPUs. But LLMs don't need to reason like humans in the same way. They could theoretically learn patterns of machine code or CPU instructions directly. What you're proposing is essentially an AI model that generates executable binaries directly, skipping human-readable code and traditional compilation. This idea aligns with what's been envisioned in areas like neural compilation, end-to-end differentiable programming systems, AI to hardware co-design, benefits of direct binary generation, efficiency, no need for a compiler, the model compiles as it generates. Optimization: an LLM trained on a wide range of compiled programs could learn machine-level optimizations better than many compilers. Reduced complexity, fewer moving parts in the pipeline. Hardware-specific, AI could tailor output to the exact processor or architecture. Major challenges: opaque output. Human-readable code is useful for debugging, maintenance, understanding. Binary is not. Security and safety. Mistakes in binary code can lead to catastrophic bugs, hardware faults, or vulnerabilities. Portability. Direct binary generation is inherently hardware-specific. Verification. Verifying correctness and safety of AI-generated binaries would be difficult without intermediate representations. Where we're headed, we're already seeing trends toward what you're suggesting: LLVM IR generation by AI models, skipping C or Python altogether. Differentiable compilers, optimizing machine-level code using gradient descent or reinforcement learning. Hardware synthesis tools that generate chip layouts or FPGA bit streams directly from higher-level specifications, AI-designed chips, for example. So, yes, the future of AI-based software development could very well skip traditional languages, using LLMs to generate optimized executables or hardware representations directly. This may eventually look less like programming as we know it, and more like specification and goal definition, with AI taking care of the rest. Would you like a breakdown of what such a system might look like architecturally, or how training would work for a direct-to-binary AI model?